pleasure to introduce Professor G. Sun, who is joining us from Cal State LA, where she's a professor of psychology. Professor Sun received her BS in cognitive science from UCLA, her PhD in both cognitive science and psychology from IU Bloomington.
Yeah.
And then she completed a postdoc at UCLA before joining the faculty at Cal State LA. Her research addresses fundamental questions about how people learn and transfer knowledge, and her work has appeared in leading journals, including Cognition and the Journal of the Learning Sciences, which those two don't always go together. She's very special. And Educational Psychology Review as well. She's especially known for her influential studies demonstrating how simplifying learning materials can support stronger generalization. And her research has been supported by the U.S. Department of Education, the Chan Zuckerberg Initiative, the Gates Foundation, the Valhalla.
That's Intuit money.
And the state of California. A piece, though, that I think is especially relevant to a Notre Dame audience is that she has an article called Following the Mentorship Model of Jesus, the Role of Storytelling. And in it, she draws on the learning sciences to argue that educators can learn from Jesus's mentoring style and using storytelling as a pedagogical tool. And because it makes learners make these connections that allow them to have deep, lasting knowledge that's transferable. Also, G has recently written a McSweeney's satire piece. You must Google this and look it up, and you will not be disappointed if you do it. And finally, G is also co-founder of CourseKata, and this is an innovative platform for teaching statistics and data science through improvement science and a community of practice. And her work exemplifies research in action. And so we are just delighted that she is here today to talk to us. So please join me in welcoming Lisa.
Thank you all so much. Thank you to Nicole for inviting me and Era for sponsoring the speaker series. I just feel so honored to just be here at Notre Dame in the cold. I busted out my mittens just for you. I know. People are telling me that. And we were going to schedule this in January. And I was like, good thing I came during the heat wave. So you guys are going to learn a lot more about CourseKata today, so we'll get to that. But for me, the reason I do science is to impact the world. I know, crazy, right? It's not to just keep it to myself and to other scientists, right? And it's all about how do we make learning science go out there and help the people that it needs to help, right? And I would like to say a disclaimer. I'm going to make a lot of jokes. I'm going to say a lot of strange things. Any of the good stuff is probably these people. All of the questionable stuff, that's me. That's 100% me, okay? But honestly, my colleagues, co-founders, fellow researchers, they deserve so much credit. And I'm so thankful to work with them every day. Okay, well, let's start here. What do we really want from education? And I'm going to argue transfer, right? We want them to take what they learned in the class, go out there in the world, and find it useful. That's transfer, right? Unfortunately, that's a lot harder than it looks, right? It seems like, it's obvious, but it's also not obvious. So let's think about intro stats. 1.5 million college students take intro stats every year in the US. Right now, somebody's intro stats class, right? They learn all this stuff. Boom, 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 boom. Each thing is hard to learn, actually. Confidence intervals, not easy. Regression, not easy. Everything is a struggle, but they learn it. Amazing. Don't we want them to now go along and think, homelessness. Oh, do you think the rents could maybe help us predict homelessness, right? Oh, inflation. That's a big thing. Oh, prices are going up. Oh, Can we use statistics to help us understand inflation? NVIDIA has these amazing AI chips. What's so amazing about these chips? Is it the size of the microprocessors, the speed? How do these things relate to one another, right? I would hope that in all these different situations, students who took an intro stat class would think, I think statistics might be helpful here. But is that what happens? Well, I would love it if students said, hey, in all these situations, I could apply ideas such as regression. It's not the only idea, but I could apply an idea like that. And wow, am I thankful that they taught me that in intro stats. But often that is super hard. This idea of applying concepts in new situations, of coming to homelessness and thinking regression, that is incredibly hard. It's the point of education though, right? If they can't do that, what are we doing? So how do we do this? Here's another point. One of the ways we teach regression is that students often don't realize it's exactly y equals mx plus b, right? They think, oh, functions. You could just forget about that. I'm learning statistics now. Think about algebraic functions. That's like a high school algebra thing. Not relevant here. I'm like, very sad. That makes me very sad to hear that, right? And so they like just don't even like, it's like not even in the universe of things they think of when they see data. Also not transfer. So let's think about why transfer is hard. When they learn regression, they might learn it with an example. Often that's what happens. They have some sort of example. Let's say this is like rents predicting homelessness. Cool example, right? Whatever example they use, they learn it, right? And then they go off into the world and they see other data in spreadsheets and people ask them questions like, oh, do chips with smaller processors also fit more processors onto them? They're like, good question. And it's like, any statistics concepts come to mind? And they're like, I don't know anything that can help me with that. I learned about things to help me with homelessness mostly. And that would be great if they were choosing one of those concepts, but in fact, about an hour after the final exam, this is what the inside looks like. So it's like everything's kind of degraded as well, right? So it's like, my chances of remembering regression are real low, right? So instead of teaching regression like that, how do I teach regression in a way where I could build transferable knowledge in complex domains? And it turns out we have like whole fields that are devoted to this question. One of them being the cognitive sciences, the learning sciences, educational psychology. Like this is like what we think about like all the time. I know, right? Like we're just sitting there thinking of theories on theories and theories and writing papers. And I don't know why that's not making an impact on the world, right? So I want to talk about one way of summarizing all the findings of the cognitive sciences that have to do with this question. And this is called the practicing connections hypothesis. So it's a little glib because I'm trying to summarize a whole lot in like one slide, okay? But the basic idea is if you have concepts, but they're not connected to each other, then they're kind of hard to recall. Anytime that you don't immediately think of that concept, nothing reminds you of it. But if you have concepts that are interrelated, even if the first thing you think of is not particularly close, it might remind you of a different concept. And that might remind you of a different concept. And that might remind you of a concept you really need for this situation. So ultimately, you need the connections. So how do you get the connections, right? Well, you get the connections by practicing making the connections, right? It turns out it's not enough for me to know all the connections. It turns out that my students have to make the connections in their minds, right? So I have to show them the concepts in such a way where it feels like, what do I do, guys? What should I do sure. And they're like, why don't you connect them? And I'm like, great. Yes, that's what we should do, right? And so I want them to make the connections, not me just telling them what the connections are. Notice that that's a little bit different from like mastery of micro objectives. Like do this until you get 80% of these types of problems, right? That's very different, right? So this is the basis upon which experts are able to transfer. They're able to transfer because experts in lots and lots and lots and lots of studies have a ton of connections. Experts often have fewer tightly connected structures, whereas novices have like a bajillion things that are not connected to each other. Right? So let's return to intro stats. What connections should we practice? Because connections, unfortunately, it's like a n factorial problem. There's only, I have a finite amount of time in a semester, right? So what connections should we practice? And one of the common things that people do in intro stats is kind of a decision tree model of connections. What is your outcome variable? Is it categorical or quantitative? How many categories do you have? Do you have 2 or more than 2? Do you have, like this is the kind of thing. And then you figure out, do you do a t-test? Do you do a chi-square? Do you do an ANOVA? Do you do a regression? The thing, and then also there's like a bunch of this decision tree that we just don't teach. We're like, shh. I guess you could have a categorical outcome with a continuous predictor, but let's not talk about it. Right? It's complicated. You have to learn about logs. And who wants to teach logs? Not me. But what ends up happening is I think I kind of hope that students would have the decision tree in their minds. But I did a lot of research trying to cram the decision tree into their minds because I really thought, get it in there, it shall serve you. Trust me. And it didn't work. They still had this at the end of the day, like a grab bag where they would just pick out one at random. Okay. And still I had this problem where something like regression would be like 1 bit, and it would be very weak, and like some percentage of students would randomly remember it and others wouldn't. Those students would remember t-tests, and I couldn't get them to remember both. Right? So instead of putting something like regression off as like a leaf at the end of a decision tree, what if we changed everything to point to the idea of a statistical model? If you ask a data scientist or a statistician, hey, what's the most important idea in statistics? They would say, oh, data equals model plus error. Now, if you told that to an undergrad, they would be like, I guess you could solve for error or something by subtracting all from both sides. They would be like, why are you telling me that? That's a totally useless concept. Whereas experts feel like, no, that summarizes all of stats, right? You see what I mean by experts? Tightly connected. Everything is one thing. SEM, ChatGPT, it's all data equals model plus error. But to an undergrad, they're like, that makes no sense. But what if we taught everything, including the mean, standard deviation, the bread and butter stuff, right? Regression, confidence interval, hypothesis testing, p-value, everything. We tied everything to the concept of model so that you have a shot of remembering the concept of model, because we're going to hit it 50 times from all different angles. You may forget S-pool. You may forget all these little details, when to have square root of n and when to not, when to have n-1. You may forget all the details, but at the end, you will have this really strong concept of what is a statistical model. And then the other stuff you can kind of relearn, probably by using ChatGPT, right? This was our hypothesis. This is a version of the practicing connections hypothesis, but implemented in intro stats, right? And so we would say this connection to data equals model plus error, that's what makes knowledge coherent, right? And the theory is that coherent, interconnected knowledge is transferable. And by transferable, we mean two things: that you could transfer to novel contexts, Big Mac prices, homelessness, chips, whatever. But also to more statistical methods, that you could learn more complex models if you knew the basic idea of kind of modeling 101, right? Okay, so then I'm like, yay, I did it, science. Good job, me, right? And I can say, I wrote the papers, wrote a lot of papers actually. And then you know, all those 1.5 million students and their instructors, I'm like, you're welcome. Right? No, totally useless to almost everybody. That community college faculty member teaching intro stats and teaching 6 sections, not reading my papers, right? Okay, so let's take a step back. We have this scientific idea. We're trying to use the learning sciences to make learning transferable. But how do we get from scientific innovation to like change the world, right? I want to tell you a story about penicillin. You guys know penicillin? Everybody, if they know a story about penicillin, it is the Sir Alex Fleming went on vacation, came back, and the petri dish did not have any bacteria, but it had this magical fungus. And ... 100. So that was like in 1920s, right? ... Today, penicillin has saved on the order of 200 to 500 million lives. Isn't that amazing? Right? And so I think a lot of times when people hear this story, they often think, well, he discovers it, and then you start off by saving 10 lives, 10, 100, 1,000, 2,000, and then up to 1 million, and then 100, 200, 500 million. That's how science works, right? But I'm gonna ask you. Oh, so this is gonna be my metaphor. I can never present anything without a metaphor because Jesus. I love that I can make that joke in this room. So that's this is the like what happened in between 1928 and 2025. That's the numbers I had for this estimate, right? I'm sure 2026 same. Right? Happy ending, millions of lives saved. How did that science get there? Right? Let's take a step back. In 1941, how many lives do you think penicillin saved? Right? It was 3. Right? They only gave it to 5 people. Just died. It's not good for penicillin. Right? Because it turns out you just can't like give mold to people. Oh. No, it's gonna be real good. The end of the story, 200, 500 million lives saved. But in 1941, things were not looking good for penicillin, right? Gosh, it's not good. Because I think we tend to value the like big innovation that happened in 1928. It's like, boom, penicillin was discovered. And then you don't even know about the rest of it. And then it's like, 200, 500 million lives saved. But it turned out that there was a ton of little tiny innovations that had to happen in between discovery and millions of lives saved. For example, they had to figure out how to purify it, because you can't give people fungus. They had to figure out how to dose it. They had to figure out who should get penicillin, because not everybody benefits from penicillin. They had to figure out how to convince doctors and nurses to give penicillin, right? Because it turns out they're not just like science proven. Ha! Doesn't work that way. They are people, humans, who need persuading. So there's a ton of little innovations that we don't think of in our minds, right? And I want to put a name on those innovations. Those are called implementation science. It's how to get the thing implemented in the world, right? And a lot of those things may not sound exciting, but how to make a ton of penicillin That was a big problem. We needed the war machinery of World War II in order to give us the engineering minds being put on it to like come up with that. That was a huge deal, right? But many of us don't know that as part of the story of penicillin. The story of penicillin goes on today with antibacterial resistant forms of all kinds, right? And so that's a huge issue today. So implementation science, still ongoing. It doesn't stop. So now let's apply that metaphor to learning science and education, right? We have researchers come up with an idea, our version of penicillin. And then we hope somebody will design something that could be shipped out into the world and then impact the students and the instructors, right? But I think this is a wishful path because mostly researchers produce papers that people don't read, it turns out. Shocking, I know. And then designers make stuff, and then instructors are like, I can't use this. And they duct tape stuff together and do that in their, or they're Googling on teachers pay teachers at 11 o'clock at anybody who's a teacher in the room, right? Like you're like making a worksheet, right? So they're like duct taping stuff together, right? And what I argue that we need is implementation science. We need something that helps us go from the innovation out to actually making a difference in the world. That took penicillin over 100 years. I am an Asian lady. Statistically, I'm gonna live a long time. That's just statistics. I don't have 100 years. You know what I'm saying? So we're not gonna do that. We are gonna be smarter about this. We are going to reorganize how we do research. So we call this the better book model or the better book approach. It's implementation science for learning sciences. And the idea is that we get researchers, instructors, and designers to work together as a community on something that's shippable already. The thing that students are actually already using and can be used to improve that thing together so that not every improvement will be a paper, but every improvement could impact students. So we made a bet on IntraStat because we're like, there's a lot of people teaching that and a lot of people struggling with that. Out of those 1.5 million college students that take that class every year, about a third fail. Isn't that a bonkers number? That's wild to me. Every time I lay awake, wow, right? That's what I think about it. Right? So we're like, that's a worthwhile problem, right? If we impact any of those people, that'll be a dent in the world, right? So we built the MVP, the thing that we could all start working on. And we call it the MVP, a minimum viable product, because it's a hypothesis, but we're pretty sure it's not gonna be great. I know, isn't that crazy? Usually when you build something, you're hoping like, this is gonna really make a difference. And we're like, no, we think this is gonna be fine, at best. It's gonna be simple, right? But we will learn by people being out there and trying to use it. And then they will tell us, here's what's wrong with it. And that's what we wanna know. And then, so we have to make sure to instrument it to give us the data on what's wrong with it. It's kind of a weird way to design a product. Instead of thinking about it as, we're just gonna give it our best shot and close our eyes and not look, we want to build a kind of product and instrument it so that we can improve it in situ. So that's why we started CourseKata. The teaching materials, they emphasize connections. Everything is tied back to the idea of data equals model plus error. We use the general linear model notation, which really freaks people out at first. They're like, what are those little eyes doing? And we're like, don't worry. After this, you're gonna be like so cool with us. It's computational, so we use R. And we're using R with many students who feel very scared of coding. In fact, many of our instructors have never used R before teaching with these materials. And we also really work hard to incorporate the real world at all time points because we think they need to constantly practice making those connections, practice looking at situations and thinking about stats, right? That's how you make those connections. And we built this minimum viable product so that it could actually serve the way that real people teach. Because we built an interactive textbook and you could actually code in R right in a learning management system. You guys use Canvas, so do we, lots of people do, but we support a lot of different ones. And we also have a set of in-class lessons as well that are very kind of project-oriented. Every day, it feels like you're diving into a cool data set, like it's about Big Mac prices or homelessness or catfishing, right? We were talking about having a data set on situationships, right? Yeah. You learn more than you wanted to. So just to show you what we mean by an interactive textbook, so the pages of a textbook, you suck it into your own learning management system. So in this case, it's mine from Canvas, right? And you could actually do questions in there. There's videos. Unfortunately, they have me in them. Students don't watch them. That's the key. Because we know, right? And you could also run R code right in your learning management system. You don't have to like install anything. Right? So it's very gentle on-ramp for students to keep their focus on actually coding rather than the installation of R and RStudio, because that's the worst. And so we support a number of different learning management systems. That's just a few smatterings, but there's lots more. And part of why we did that is that's how you make it helpful to an instructor. They use learning management systems. So if you're going to design something, it better fit into how they're thinking about teaching, how they organize their class. And then we also had to add in professional development. Because lots of people were like, I kind of want to do this, but I didn't learn with a modeling approach. I want to do this, but I never did project-based instruction to undergraduates. I didn't lecture like this. So how can I do this? And so we started having these professional development communities as well. But here's the thing. We fundamentally believed that our textbook was not that great. And we needed to instrument it with data, right? We needed to figure out how to collect data on where is it not that great? Precisely how not great is it, right? And so we really have a 12-chapter textbook. The 13th chapter is more of a review, but what we have is lots of embedded questions, like the ones you saw, little coding questions, little, open response, all kinds of things, right? We have embedded questions, but we also track students' engagement, their active time engaged, their clicks, all that kind of stuff. And we also have psychological constructs called pulse checks at the beginning of every chapter, because we want to know where are they dipping or when is motivation waxing and waning. And here's what a pulse check looks like. I want to briefly show it to you so that you could, we're going to come back to this pulse check idea. This was a very small, brief 4-question survey. So it feels very light to students, like they do it in 10 seconds, right? And it's basically how confident are you? Like, do you find this stuff relevant? And also the last one is, I'm unable to put in the time needed to do well in the previous chapter. And we call that psychological cost. Like they just feel like, it takes me so much time and effort to do well in this. It's not worth it, And so those are the pulse checks where we think of them as literally like, we're just checking, are you alive? Are you okay? Are we going? And we also have a number of surveys implemented throughout in 4 different time points where we also ask questions about mindset, math anxiety, all kinds of things. And so if you're interested in modeling this data, we'd love to have you. And if you're interested in collaborating with us, we'd love to have, we have a lot of data to analyze. Okay, so now we have it. We have this thing, the course materials in the middle. It's going to give us data in a continuous stream. Now we need to build the community. Right? Because to us, that is the power of the Better Book model. That's how we're going to not have to wait 100 years for all the things. We're going to have everybody working on it now, right? And so we have researchers, instructors, designers, and developers working together from over 150 different institutions. Some of them are just instructors who are just using it. Some of them are instructors and researchers. Some of them are just researchers. Some of them are designers. We have lots of it. This is not 150. This is how many I could fit on the screen. And so one of the things we're always trying to do is figure out different ways that people could collaborate where it feels very productive and helps move us along. So let me give you an example, a couple of examples of what we've been able to accomplish with this community of better book improvement. So here's a tiny, tiny data-driven change. So we make so many of these changes that we don't write papers because they're just tiny, but they're tiny improvements, you know, and it's not making a huge difference in their lives, but hopefully it makes a tiny difference in their lives. We try to teach people about box plots and the 5-number summary and quartiles and all that stuff because we're a regular stats class, right? And we say it is important to note that what is important about the 4 quartiles is the number of data points included in each. And this was an old figure that we had in there. And down the page, you see this question. The quartiles are equally sized. What is equal about the quartiles? And about 50% of students get this question right. And if you look at the misconceptions, they are the ones that say they have about the same range, the same interval. And we thought, ooh, I think we gave them that idea with our little figure, right? And so an instructor had designed a little figure that they used. So we put that figure in. Right? This is an example of an instructor being like, this is dumb. I'm gonna duct tape my own version together. And we're like, great, can we use that? Right? And so we put it in, and here's what we found in the next semester, because there's always people taking interest eds. The next semester, we asked the same question, and here now 84% of students are known. So it's a tiny improvement. We've not changed their lives that much. They will probably forget this fact, right? But we're hopeful that we could make hundreds and hundreds of these kind of tiny little changes based on real data. And also, I want to point out that these instructor innovations, that little figure could have just impacted their 30 people. This was a community college faculty member. They teach about 30 people in a section. It could have stopped there. But that little innovation was able to be scaled to 150 different schools that nobody even knows Ben Smith. But he doesn't need that. He could get his innovation out there at scale easily. Example 2. This is one of those things where it's kind of like the nurses and doctors who were skeptical of penicillin. They were like, I don't know about this penicillin business. We have a lot of instructors who are like, gee, you seem like you could get people to do things that they don't want to do. But I don't know about my students. I don't know if my students could learn that our coding stuff, right? We hear this a lot, right? And we felt like it is important for us to do the research to actually alleviate people's concerns. And so one of the things we found out was that the most threatening part of programming to most students was installing the IDE or the coding environment. They were like, once they were doing that and they were like, I can't find my file that I downloaded. I don't think I'm a coder. And I'm like, no, that's not the coding part yet. And we're like, yeah. So I was like, definitely not alleviating people by telling them it's not coding yet. So we thought, that is extraneous cognitive load. That has nothing to do with whether you could do some coding, right? And so that's why we integrated R into the learning management system. You saw how we did it in the textbook, but we also have a way where instructors could just create a Jupyter notebook, which is a runnable computational document. So it just looks like a document, right? But you could put images, text. But the important thing is it's a document that could run code. So you could put little examples in there. Students could fill in things. They could see it right there. And it's all in one place. And there's a submit button at the top and they submit it and it goes right back into Canvas. right? And so these are the kinds of things where we think it's not something that an individual instructor can do. I mean, a truly amazing instructor can, but that would be trapped in their class. But we wanted to make this available to everyone. And we looked at what the shifts in attitudes towards R, and these are community, this is California schools, community college, CSU and UC, and we see these shifts in almost all these classes. And so this is just one of those classes where at the beginning, a lot of students are either neutral or like, there are a fair number of students, half the students are pretty anxious about it, right? And towards the end of the class, we see, oh, we've really flipped that. We've really sold them on R, right? And we were particularly interested in the students that started off as like ones or twos in our attitude survey. Like they were like real, like, I'm not happy about this, right? It turns out that there's about like 250 of those students in this class or in the sample, and 150 of them become 4s and 5s at the end of a semester, right? And so we are able to shift them in their attitudes, and we have other data showing that that shift comes not too late, like it comes around chapter 4, right? So people are pretty anxious for the first week or two, right? But once they hit chapter 4, we really see this flip. But it's not just college students. We just replicated all of this with high school students in 5 different states, right? And so, and we did a literature search, but it turns out nobody looks at high school students learning R. So we feel like we're the first, you know? And one of the things we find, you know, good things go up, bad things go down. For example, confidence in their R coding shoots up. Things like anxiety go down, right? And so even high school students, they learn it over a year. So it's a little bit different, but they also improve in their R coding. And so tech tools that are impossible for a single instructor to build and implement can be implemented, put out into the world, and improved at scale, right? So we could do more. So those are some little examples. I want to show you one example of a big change. So we have a lot of equity gaps in intro stats. Tons, everywhere you look. It's a highly replicable effect, right? How do we work on it? There's kind of 2 approaches to addressing equity in education. One is kind of this individual change, like you find the people who are like whatever the gap is and you try to like raise them up somehow, right? Or maybe you try to hammer down the people who are already high or something, I don't know. But that's the individual change approach, right? We wanted to explore a systems change approach where we change the system to produce different outcomes, hopefully more equitable outcomes, right? And so the Better Book approach is an example of a systems change approach. We're going to change the textbook. It's kind of like a tiny example of a system, right? And so we are called CourseKata because we're always using this improvement kata, right? If anyone takes martial arts, it's like a practice routine, right? And we always have this vision or long direction that's like going to take us 10 years. So, you know, reducing equity gaps, that's like a 10-year, more than 10-year kind of goal, right? But the current condition was we needed to disaggregate the student data by racially marginalized groups versus non-racially marginalized groups to try and figure out where are the equity gaps? What equity gaps, right? And then we're going to try to redesign the textbook and evaluate it all in this system, right? So I go back to those motivational pulse checks, right? We're asking those pulse checks all the time. Students are doing it at every chapter. We have these different measures and we're like, hey, do students experience motivational gaps in any of these? And what we found was kind of surprising to some people. When we look at what's called success expectancy, like your confidence, like how well do you think you learn that stuff, we found no gaps between racially marginalized in the dark solid line and the dotted non-racially marginalized groups. And these are students from the state of California, right? And so our racially marginalized group tends to be a majority Latino. We also found no differences in intrinsic value or utility value. That's like how useful or interesting it is. But where we did find big gaps was in cost. And so we zeroed in on this pulse check. And it says chapter 8 right there because it's at the beginning of chapter 8, which means it's a reflection of chapter 7. So we zeroed in on 7 because we just needed a place to start, right? And so we looked at every single piece of feedback we got back on that. We had student researchers from diverse universities being like, they were like our researchers / focus groups. We also had a variety of instructors weigh in. And we got those perspectives and redesigned vast swaths of the textbook, right? And this was a hard thing to do because you're trying to balance everybody's feedback, right? And this is also kind of from a scientific perspective, kind of terrible because we made 10,000 changes, right? Which one of those changes is important? I don't know. We're just trying to improve it, right? But let me give you an example of one of the huge changes we made. This is just one. One of the things we found was that students said, chapter 7 just feels so long because it was long. It had twice the number of words as every other chapter. So we split chapter 7 into 2 chapters, chapter 7 and chapter 8. That actually made instructors spend more time on that content because instructors, they look at chapter 7. They're like, I'll spend a week on chapter 7. Oh, chapter 8, I'll spend a week on chapter 8. That's kind of how they plan, right? And so because of that, it really changed how they taught, right? We made a whole bunch of other changes as well, but this is just one example. And the changes were all throughout the textbook, not just in chapter 7. But we always call chapter 7 the most hated chapter. I literally cried rewriting chapter 7 because I'm like, this is so bad. How did we make students read this? I felt really bad. Okay. So we looked at this data again, and we looked at version 4 of our book. This was before we did the redesign. Verified gaps. Replication. Great, right? And then we looked at version 5, and there were no more gaps, except in chapter 3. And so version 5.6.2 came out, which redesigned chapter 3. But we did that same process. And so to us, this is a systems method of improving equity outcomes, right? We're not looking at individual students and being like, how can I change you? How can we change the system? And what we found was that in some ways, our racially marginalized students were like canaries in the coal mine. They told us they hated it for reals. But everyone kind of hated it, right? Other people were just like less hatey, And so what happened was that all cost rates went down, writ large, So we really think we could tackle systemic issues by tackling systems level improvement. Okay, and here I'm going to get a little hand wavy, okay? Because this is about the future. Because I don't know about you, but we're all having a moment right now where we're all a little worried about the future of education. It's kind of a thing out there. Everyone's like worried. People are calling it the post-literate world. It's like a lot of hemming and hawing, right? And it's a time of anxiety, I think, right? But instructors don't have to face this alone if we're doing this in community, right? Because part of it is that educational systems, for better or for worse, we've always been about the transformation of students, right? We want students who come in and be different at the end. And the way we have measured how different they are is with like outcomes and products and deliverables. That's what we've always done. And then comes bag of words AI. That's what I like to call LLMs. They're just like generating words at you, right? And it really shakes us because all of a sudden it's really good at these outcomes, products, and deliverables with no student transformation needed. And we're all like, oh no. So what shall we do? Well, one of the things that we're doing is we're leveraging the community to create and test new assessments. And we're trying to use this as an opportunity to get down to what we actually value. We actually value students transforming. That's the thing we value. So how could we actually measure that? We don't think we have the answers, but as a community, we're able to try a lot of things. If I only teach one, usually I teach like one section of stats at a time, right? I can only try one thing in a class. But if we're working together with a lot of people, we could try a lot of things, right? So a couple of the things we're trying are performance assessments, assessments of preparation for future learning, and learning trajectories. And so I'm just going to quickly tell you a little bit about them. So performance assessment is like, you know how like if you go to a piano recital, that is the performance, right? You're not seeing the practice, you're seeing the performance. So we thought about, what do we actually want students to be able to do? What is the recital of statistics? And we thought, oh, it's this, it's real sexy. You give them a spreadsheet and you ask them a question. And you say, go.
This is true.
We think that's the recital of statistics. And we'd hope that they would apply math and stats and whatever else they've learned in order to answer those questions. So we gave students a spreadsheet. We asked them, hey, are longer passwords harder to break? And we said, go, right? So this is actually a study we're doing right now. So I have a little bit of data, but one of the, you don't need to read all this, but one of the things we could start to do is we could start to triangulate. Here are the things that a lot of students are actually quite good at. There's a bunch of them. Here are the things they all kind of suck at, right? And so, you know, for teachers, it's helpful for them to know it's not just your students. It's like everybody struggles with these, right? And then we could take a systems approach to try and help, right? So here's another example. The idea is that if you learn something, that should help you prepare for the future, right? Where presumably you will have to continue learning because that keeps happening, it turns out. And so we wondered if students learn models where X is used to predict Y, could they generalize to a model where both X1 and X2 are used to predict Y, right? Because that's where I'd hope that you would go. We have a whole paper on this, so I'm just going to summarize this as yes. Students can learn this. We asked students at the end of a statistics class, it was in their final exam, we put in a few questions and we said, this is just extra credit. You don't have to get these right, just try your best. And we asked them to generate the GLM, general linear model notation, for this two predictor model. And more than 50% got it exactly right. When they got it wrong, you know what they got wrong? Those effing eyes. The little, right? But that's fixable, right? That's actually something where if you came in and you needed some help with the eyes, we could work on that, right? But they were kind of in that ballpark. Also, more than 80% of students, they were able to reason correctly about proportion reduction in error, or R squared, right? That concept. They were also able to reason correctly about the sum of squared error left over after the complex model. So they were able to reason about things. They weren't able to calculate that, but they were able to predict in which direction they would go, and they had good reasons for why. Now, if we're in the business of transforming students, maybe we should assess their journey, not to grade them, not to like stamp them at the end and say, you are deserving of going to med school, not like that. Just for us to know that we're transforming students, right? And so another thing that we're doing is assessing their journey. We collect a lot of data on these students and we want to know, what is your walk like? Right? And so this is just very preliminary data that Dr. Claudia Sutter threw together for me. I was like, oh, can you clean up the visualization? Thank you. So here's some preliminary data. So what we find is basically 4 clusters of students. We have highly engaged, consistent workers. They're engaged, they're motivated, they're like in it to win it. We have low engagement, moderate completion. They're like getting it done. but they're doing it best. We also have consistently disengaged, lots of NAs. They're like not even going to the page. And then we found a group of recovering engagement. They're slow to warm. But after about chapter 3 or 4, they start to pick up, right? And so these are the kinds of things we'd want to look for. And we'd want to try to change the materials so that we could get more of those low engagement people to become, recovering engagement people, right? Or maybe some of those consistently disengaged people, getting them to be like, recovering engagement. Or maybe we could get the recovering engagement people to become more of the highly engaged people, right? So we want to change the kind of walk they're having through statistics. And so all that stuff, there's so much more that we're doing on assessment because we really think there's so much that's changing about assessment. But really, as a community, we could go farther faster, right? Because it's not just my classroom as a laboratory, it's many, many classrooms as a laboratory. So I want to close by just helping us think, what is the role of scientific innovation, right? I think it really has to be seen in the context of implementation. Don't judge the innovation by the innovation itself. Judge it by how much of an impact it's having in the world. And if that's going to be how we judge it, we need to rethink, we as learning scientists even need to rethink how we conceptualize our problem space. Like a lot of times as a learning scientist, I'm thinking about my one sheep and making sure my one sheep has a great interconnected experience, right? But I gotta also scooch back a little and also think about my class, right? And try to keep all of them in mind and the variation that exists in mind. But then I think we need to go a level up, right? We need to keep in mind this is happening at scale out there all the time. Right? How can we make an impact? And that's happening within schools, within structures, within departments, within universities, within districts, within states that have policies and culture and all the other things that it goes with, right? So I fundamentally believe in science, right? I really believe in this learning science stuff. I think that's really important. But I also think it needs to be kept in context of changing the world, right? And so if we want science to change the world, we have to understand implementation. It's got to be part of the science, right? It can't be just like, well, I'm just going to do the innovation part and hopefully someone else will do the implementation. Instead, I want us to join together, create a community where we really believe in this goal, right? And so that's why I think the ultimate, we have a lot of tech, we have a lot of data, we have a lot of stuff, right? But I actually think the most valuable thing about us is our community. The fact that we've gotten these people who are pretty diverse and disagree with each other on lots of things to work together and start rowing a little bit in the same direction, right? And so not every improvement becomes a paper. But every improvement affects thousands of students every day, right? And so for us, we think that's the kind of science that makes a difference in the world. So thank you so much. And I want to end by saying, please keep in touch if you're interested in learning more about CourseKata. If you're a grad student, we have a summer institute that is tailored for graduate students who want to learn more about the learning science behind teaching intro stats. If you think you might one day teach intro stats and you're like, hey, I'd love to get more of that learning science behind it, please join us in the summer. If you're interested in getting the slides or anything, go ahead and contact us. I'd love to get them to you somehow. And of course, thank you to all the people who have funded this work. And thank you all for being here. We have time for questions or yeah.
Hi, I'm Joe. I'm a recovering intro stats and regression instructor.
Yeah. Hello, Joe.
14 years worth. This may be one of my favorite talks of all time. just pandering.
Excellent.
I'm thinking about the really key component of transfer of the model, particularly to higher order. That's essentially critical as students move on to a full-blown regression course. But how are you also thinking about the transfer of the coding skills and the ability to use the software for higher order things, and in particular in settings where a student may come into an intermediate level class not having the same type of training, or where some of the software that is used may need to shift to something like Stata or something like that that may be preferred in the field.
I think almost everyone has some version of the problem you're talking about. It's like they took a previous course and they use MATLAB and or they use Excel, and so there's a lot of interoperability issues, right? And one of the things we always say is we teach R not because we're actually trying to make them into coders. What we actually want them to learn is algebra. We want them to know the statistical notation of the variables, but it turns out that algebra is no one's heart language. It turns out that's not the language where people feel like, oh, I feel convinced. It just shows me the algebra, right? I know. I was shocked too. I was like, say it ain't so. And so one of the things we're trying to do is help people make the bridge from R to algebra, because we think algebra, the reason why we're putting all our money in algebra is that algebra is fundamentally transferable. So if you know the algebra, we hypothesize that you could understand Stata and SPSS and all of that, right? But I think that's also one of the things where, there's a real practical consideration. Like, we want to respect the autonomy of our colleagues to teach Excel or whatever they teach, right? But we also don't want to make lives super hard for our students, right? And so that's always, I almost feel like that's like a separate psychology. It's the psychology of departments, right? I do feel like there's a lot of implementation science work to be done there. And is there a way where we could make it easy for each other to adopt something that would fundamentally serve a lot of students, right?
It's important in interdisciplinary educational research because you have the Stata people and the R people or the SPSS and I don't know what else, Jamovi, I don't know what are people using.
Yeah.
But this seems to be an issue. Yeah.
In some ways, in this world of LLMs, SPSS is the hardest thing to cheat on, actually, because you have to point and click your way through it, right?
There's syntax.
That's true. It's, which is so hard to learn. I've learned a lot of coding languages, and SPSS syntax made me want to gouge my eyes out. And have you ever tried to make a figure in SPSS? Oh, yes, you should give up. Just lay down. Don't make a figure in SPSS. You don't do it, right? And so, we're trying to figure out, that's actually one of the reasons we picked R. Yeah. Because a lot of departments, they didn't even have in their learning objectives be able to make a publication ready figure. Mm-hmm. How important is that skill? If I had a student who could do that but didn't know what a t-test was, I'd take him in a heartbeat. Right? It's one of those things where I think, and at least in our department, we don't want to change our learning objective. You know how hard those things are to change. They're set in stone, right? And so we're slow at changing those things, but we all kind of agree that it's really important to make publication ready visualizations, right? Mm-hmm. So how are we, that's one of the things that the CSU is struggling with. How do we adjust as quickly as the world is changing? So that's one of the, it's not a great answer to your question. Apologies, but good things.
What I really love is the high expectations that people can learn art. Yeah. And that's a fundamental mindset shift that I think a lot of instructors need to take into account, particularly teaching undergraduates or teaching, intro stats grad students who may have been away from formal education for a period of time.
But I always love those students who come back to me and they're like, oh, look at this cool thing I learned to do.
I really, really enjoyed it. As someone who has been teaching, who has taught undergrad stats for 18 years now, a lot
Thank you
of
for your
things that you
service.
said resonate with me. And as someone whose research is in assessment, I'm very drawn to the last piece that you talked about regarding performance assessment. So what you did exactly that you showed with the spreadsheet, followed up with questions and so on, is very similar to what they do with a certification exam for accountants, so for CPAs. So how they are assessing whether someone has the skills, has the ability to be certified, to be a certified public accountant. So very interesting. And some of the research that we're collaborating with them involves looking at the process data. So not just how you answer the final question right or wrong, but how you arrive at the answer, because sometimes you have like, expendable menus that they can pick things, they can move things around. So all those processes are very informative in understanding the patterns of how learners think or problem solvers think. They may be using different strategies and so on. So I would be very interested in learning more about that and talking to you more about that.
Yeah, this was the data I showed was just, we tried to make it, actionable for instructors, because these are people who are teaching one semester stats in various universities. And so it was designed as like a 1 hour exam. So it's like a very brief project-based exam, right? And it was in the form of a Jupyter notebook so that they have the data, it's all there, it's ready to go. And also importantly, we didn't have the data were very clean. You can make that so much harder by just adding in a period randomly somewhere. Oh, that'll make it really hard. But we didn't do any data, but you could kind of titrate the level up and down. You could ask harder questions, more open questions, different things like that. And so that was our kind of first shot, but we'd love to think more about how to, expand it out, shrink it down, so that it's for different use cases. And one of the projects I didn't talk about is we're looking at machine learning models to predict from their textbook interactions how well they do on this, right? And also, one of the things we were really interested in also was how similarly high school students and college students did, right? I mean, they're different. The high school students are a little bit worse, but they're not that much worse. And it's a matter of degree rather than like, qualitatively different, and even in different universities, because we have universities like, elite, Stanford, Princeton, as well as community colleges. And the fact that a lot of these students could come to the same sorts of competency, that's one of the things we're really interested in. Because, accountants, they could be trained anywhere, but they're all tested in the same way.
And so I teach at John Adams High School. So I teach high school students. I'm in the IB department, and my class is mathematics, application, and interpretations. So we do all of this stuff. And it's kind of interesting because my kids are the low-level kids. They don't want to do the calculus. So we do some calculus, but we do mostly statistics. And it's interesting because my students are able to access the data a lot easier than some of the higher level students. And I'm wondering, and I'm curious, and I actually inquired a little bit about, is it because of that algebraic understanding? There is a difference of approach when students are looking at data from a lower level than a higher level. Yeah. And that happens too as well when you ask adults a question versus ask elementary students the question. Mm-hmm. They answer it very differently because they're coming from their different perspectives. Yeah. I don't know. So I'm engaged by it.
We published a paper called, we tried to call it a compulsion to calculate, because, we gave people word problems, and if you gave people word problems in a row, they would just, at some point, stop thinking, and then if it's like fraction addition, they just keep adding fractions. They just see the fractions, they just keep adding, right? They actually they were like, it sounds too much like a psychological problem. So they made us call it premature calculation, which I think actually sounds good. I do that, right? But the reason I tell that story is that partly we found that the better you are at calculation, the more you fall into that because you're very quick. So you're just like, I just see the numbers, I go straight to the calculations, right? I don't need to think.
Yeah,
right?
understand it, yeah.
And part of it is that if you are slow with the calculation and you're not that confident about the calculations, then you just slow down and just, you're like, oh, what's this mean?
Yeah.
You know? And so maybe that's part of it. That's very interesting.
Yeah.
Yeah. And we teach also a workshop for science majors in our university because physics students or whatever, like biochem students, they never take stats. They always take cal, linear algebra, you know.
Yeah.
And they never take stats. And then they do a thesis and they're like, I don't know what to do.
It's bad. I mean, a lot of times, even if they've taken intro,
That's all
sorry to
true.
say, they still.
Yeah, just wait 1 week after, you know.
Yeah,
To that point, sorry, I don't know your name.
Colleen O'Brien.
Colleen. So
Yeah.
Colleen was talking about the lower level students taking stats. So Santiago, who is the dean of the College of Science here, was really pushing till he became provost at Dartmouth, was really pushing like stats for everybody except engineers as like the mandatory thing because you use it so much more than calculus, and like flipping its head on like who gets stats are those who don't take calculus. And I'm just curious, there's different sides to this argument. At a meta level, why did you guys choose stats and not calculus? And do you think like that there's a strong argument there that we should be pushing stats for its utility more than calculus for some individuals?
I mean, I heard a saying from a statistician, and he said, "Someone needs stats, some people need calculus." And I was like, "Oh, that seems right to me," you know, like just intuitively, I'm like, that's kind of true, right? And you know, the big reason we started off in stats is because I taught a lot. You know, and so did Jim Stigler and the other people on our initial team. So we were just also trying to make our lives more manageable. But part of why we did stats was there's so much data out there. Also, like it just seemed like every job requires data chops. Like I was saying to someone during lunch, right? Like 50 years ago, a high school principal did not need to know that much about data. Now, high school principals are looking at data. Their job description hasn't changed a ton, right? But their job, the nature of their jobs have changed. Every job secretly has more data in it than ever before. And so we started thinking stats, it really impacts this broad swath of people, whereas calculus, it was, I would love to also work. I would love to have CourseKata calculus, you know, after I finish. You know, we think learning science should be for everything, you know, but we started off in stats just because we thought intuitively there's this like need in the world and people are teaching it a lot and we think we could connect those dots, you know? Yeah.
I am going to say that we are going to eat pizza now.
Yes.
And you know, Dee's gonna hang out and we're gonna have more questions but eat pizza and ask questions, and we're gonna formally thank her for a